Dear learners, welcome to this channel. In previous video, I have explained the first 10 questions in JAM 2020 chemistry paper. In this video, I will explain the next 10 questions in JAM 2020 chemistry paper. The question number 11, at constant pressure, the mu T diagram for a pure substance that sublimes is. Okay, we know that at low temperature, if you take low temperatures, which one is more stable? At low temperature, the stability order will be like this. The stability, solid is more stable than liquid, liquid is more stable than gas. Then when the stability of solid is more, here there is a relation between stability and chemical potential. Stability is indirectly proportional to chemical potential, indirectly proportional to 1 by mu. As the chemical potential increases, stability decreases. Suppose if you take this graph, here the chemical potential of solid is less, so solid is more stable at low temperature, and the next stable is a liquid, the next stable is gas. Okay, in this case, the order of stability is correct. Suppose if you take graph B, at low temperature, which one is more stable? Gas is more stable. What is the stability order at low temperature? Solid, liquid, gas. In this case, gas is more stable. So the graph B is incorrect. And in the case of C, solid has less chemical potential, means more stability. Next one, liquid, next one, gas. Okay, in this case, there is a correct sequence of solid, liquid, gas, stability. In this case, at low temperature, which one has more stability? Gas. Gas state has more stability, since gas has less chemical potential. Okay, in this case, in graph D, if you take graph D, this is also incorrect. You have to compare A and C. Here, the substance is sublimable. It means solid directly converts into gas. There is a direct conversion of solid into gas. So in which case there is a direct conversion of solid into gas. Suppose if you take this one, first solid, as you increase temperature, it converts into liquid. So first there is a conversion of solid into liquid. But if you take this graph, as you increase temperature, there is a conversion of solid directly into gas. At this point, there is a conversion of solid directly into gas. So this graph will be correct option. What is the correct option? C is the correct option. The force constant for H35Cl and D35Cl are the same. Force constant K is same. And both can be considered as harmonic oscillators. H35Cl has a fundamental vibrational transition at 2886 cm inverse. The ratio of the 0 point energy of H35Cl to that of D35Cl is. For harmonic oscillator, what is the energy? Energy En is equal to N plus 1 by 2 H nu. Nu is the frequency of harmonic oscillator. Here, what is the value of N? N 0, 1, 2. Okay, this one is a vibrational quantum number. 0 point energy. 0 point energy. What is 0 point energy? When N is equal to 0, the energy is called as 0 point energy. So when n is equal to 0, what is the energy? 1 by 2 h nu. So if you take ZPE, what is a ZPE? ZPE is equal to half h nu. What is a nu? Vibrational frequency is equal to 1 by 2 pi root k by mu. Mu is a reduced mass. Mu is equal to m1 m2 by m1 plus m2. Suppose if you take a ratio between two frequencies, if you take nu1 or nu1 by nu2, obviously this one is equal to root nu2 by mu1. Okay, when it is true, when k is constant. So from this equation you can write nu dc SCl by mu dCl is equal to root over mu dCl by mu SCl. Here in this question, you have to calculate the ratio of the 0 point energy of H35Cl to that of D35Cl. Okay, what is the ratio? If you take ZPA of HCl and ZPA of DCl, there is a cancellation of 1 by 2 and H terms. So finally you will get nu HCl by nu DCl. Okay, this is the ratio you have to identify. This is ZPE of HCl by ZPE of DCl. Then what is mu DCl and mu HCl? Suppose if you take mu DCl, M1, M2, here M1 is what is the weight of deuterium? 2, and chlorine is 35 and 2 plus 35. So it will be 70 by 37. And mu HCl, what is the mu HCl? 1 into 35, 1 plus 35. This is the mass of hydrogen, this is the mass of chlorine. So 35 by 36. So if you take ratio, 0 point energy ratio, you will get root over mu DCl 70 by 37 divided by 35 by 36. This one is equal to root over 70 by 37 into 36 by 35. So finally you will get the root 72 by 37. If you take this root, you will get 1.395. Okay, this is the correct option. 1.395. C is the correct option. The correct statement regarding the determinants of matrices R, S, T is, okay, here R matrix, the columns 3, 4, 1, 2, 5, 3, 4, 7, 8. In S, 2, 5, 3, 3, 4, 1, 4, 7, 8. Here there is an interchange of these two columns. Okay, when you compare R and S, in S, when you interchange two columns in R, you will get S. Okay, in this case, the determinant of R, so when you interchange two columns, you will get minus determinant of S. In case of T, here 3, 4, 1, 3, 4, 1, here 3, 4, 1. Means the column converts into row. 2, 5, 3, 2, 5, 3, 4, 7, 8, 4, 7, 8. So these are the 3, 4, 1 converts into 3, 4, 1 column, first row, and second column, here second row, and third column, third row. So when you convert all the columns into rows, then there is no change in determinant value. It means determinant of R is equal to determinant of T. So what is the correct option? Determinant of R is equal to determinant of T, but this one is not is equal to determinant of S. Okay, B is the correct option. The boil temperature TB is defined as the temperature at which the properties of real gas coincide with those of an ideal gas in the low pressure limit. Okay, low pressure limit. The graph that shows the pressure dependence of compression factor Z for a real gas at TB is. Suppose what is the compression factor? This is PVM by RT. Okay, this is the PV term of ideal gas. This is the PV term of this is the PV term of real gas. This is the PV term of ideal gas. Okay, this is the ratio between V real gas by V ideal gas. Suppose if you take Z, this is a Z and this is a P. Okay, when Z is equal to 1, this is a 1. When Z is equal to 1, then the gas is acting as ideal gas. If you take boil temperature, at boil temperature, at low pressure range, it can act as ideal gas. At high pressure, there is a deviation from ideal nature. This is the deviation. So this is at TB, T is equal to TB. Suppose if temperature is greater than TB, then the graph will be like this. This is T greater than TB. When temperature is greater than TB, this is the deviation. Suppose when temperature is less than TB, then you will get like this. This is at temperature less than TB. So this one, T is equal to TB when temperature is equal to boil temperature. This one is T less than TB and this one is T greater than TB. Okay, this type of relation you cannot find. So what is the correct option? B is the correct option. Number 15. The major product formed in the following reaction sequence is. Here you have alpha beta unsaturated ketone. In first step, this alpha beta unsaturated ketone is reacted with Grignard reagent, ethyl magnesium bromide. Okay, here there is a 1,2 addition at carbonyl carbon. So here there is a generation of intermediate. This is negatively charged ethyl group and positively charged magnesium. This one attacks on carbonyl carbon and here O becomes O minus. O minus, this one is ethyl group. In second step, this O minus reacts with chromium trioxide. This is the chromium trioxide. These electrons comes towards chromium and these pi electrons moves towards oxygen. So here there is a formation of this intermediate. So double bond O, this one is ethyl and this one is O, chromium, double bond O, double bond O, this one is O minus. In next step, this O minus attacks on this carbon and these electrons moves towards this carbon and these electrons will be abstracted by oxygen. So finally you will get here ethyl, and here double bond. Here there is a formation of CO bond, O, and this one is chromium. This one is double bond O, here double bond O, and here you have O minus. This O minus abstract proton, this one abstract proton, and these electrons moves towards oxygen, and these electrons comes towards chromium. So finally you will get this is the ethyl, and this one is a double bond. Here you will get double bond O, and the remaining part you will get. This one will react with the phosphorus halide. We know that this one exhibit Wittig reaction. In Wittig reaction, C double bond O will become C double bond CH2. So when this one is reacted with PH3, P double bond CH2, here there is a formation of ethyl double bond. Simply in place of oxygen, there is an insertion of this group, CH2 group. So you will get CH2. So what is the option? Okay, this is a structure. It can be represented as B. So which one is the correct option? B is the correct option. The geometry is different, and the shape of the molecule is different. Geometries of the species Br3 plus, Br minus, and Brf3 are respectively. Here geometry, this one depends on steric number. Steric number. What is steric number? Okay, this is the sum of bonds, number of bonds, and also sum of lone pairs in a chemical species. The number of bonds and lone pairs on central atom of the chemical species. Suppose if you take a Br3 plus, what is the hybridization of Br3 plus? Sorry, Br3 plus, what is the hybridization? You can calculate easily, very easily. Here one of the bromine is central atom. How many electrons will be there on bromine? 7 electrons. And the remaining two will be attached with bromium. Here the remaining two will be monovalent. So the number of monovalent is 2, and you have to remove charge and divided by 2. What is the value? You will get 8 by 2 is equal to 4. Okay, here you have 4 hybridized orbitals. What is the geometry? sp3 is, what is the hybridization? sp3 is the hybridization. Okay, you can easily find out hybridization of central atom by using this formula. What is the formula? This is the number of electrons on central atom plus number of monovalent around central atom minus charge divided by 2. So this is the formula. Number of electrons on the central atom plus number of monovalent atoms surrounded around central atom and minus charge by 2. So 7 plus 2 plus 2 minus 1 by 2, 8 by 2, sp3 hybridization. If you take sp3 hybridization, what is the geometry? This is the geometry. Tetrahedral is the geometry. So here this is the bromium, and this is the bromium, and this is the bromium, lone pair electrons will be there. This is a plus charge. Here you have to consider bond pairs and also lone pairs in the case of geometry. In the case of shape or structure, you have to consider only bond pairs. Here, what is the shape of the Br3 plus? The shape is bent shape, but what is the geometry? The geometry is tetrahedral. If you take Br3 minus, what is the hybridization? Simply central atom has 7 electrons, 2 monovalent atoms plus 2 minus of minus 1 by 2, it's a 10 by 2, 5 hybridized orbitals, so it's a sp3d. What is the geometry? You will get trigonal bipyramidal. First one is tetrahedral, second one is trigonal bipyramidal. And BRF3, what is the hybridization for BRF3? Here the central atom has 7 electrons, 3 monovalent by 2. So 5 hybridized orbitals. Again, what is the geometry? Trigonal bipyramidal. Structure is different, geometry is different. Okay. So what is the option? The option is C is the option. The case type structure adopted by boron hydride B5H11 is given. Okay, we have 5 types of boranes. One is closo, nido, arachno, hypo, and clado. Okay, these are the 5 different types of boranes. If you take molecular formula, this is BnHn2 minus, and this one is BnHn plus 4. This one is BnHn plus 6. This one is BnHn plus 8. This one is BnHn plus 10. In this case, what is the n value? B5. So n is equal to 5. What is the n plus 11 means? You have to add 6. So what is the formula? This one is Bn H n plus 6. Here n is a 5. 5 plus 6 11. So this is the formula Bn Hn plus 6. Arachno is the correct option. Arachno. This one, the structure adopted by boron is arachno. So D is the correct option. The order of the MC bond strength in the following species is, okay, MC bond, here there is a back bond concept. Actually, first there is a formation of coordinate covalent bond between empty orbital of metal and lone pair electrons on the carbon monoxide ligand. After that, there is a back bond. So the back bond strength, it depends on the electron density on central atom, that is metal atom. Suppose more the back bond strength, more the MC bond strength. Suppose this is a resonance structure of this one, MC triple bond O. If you take resonance structure, M double bond C double bond O. Suppose if the metal has more electron density or more negative charge, then there is a more back bond nature, then there is a more MC bond strength. Here you have to identify on which case there is a more electron density. CrCO6 0, the oxidation state is 0, here plus 1. We know that carbon monoxide is a neutral ligand, so the charge will be here 0, here plus 1, here 2 minus, and here 1 minus. Okay, which one has more charge, more negative charge on central atom? The third one has more negative charge. The next one is fourth one, and the next one is first one, and the next one is second one. So the MC bond strength will be third one is greater than fourth one, fourth one is greater than first one is greater than second one. Okay, this is the correct option. More the back bonding nature, more the MC bond strength. Okay, the back bonding nature depends on the charge, the negative charge on the metal. More the negative charge on the metal, more the back bond. More the back bonding, more the MC bond strength. The number of non-bonding electrons present in the frontier molecular orbitals. Frontier means outermost orbitals of HF is. Suppose if you take molecular orbital diagram of HF, this is fluorine, this is the hydrogen. What is the electronic configuration of fluorine? 1s, 1s2 and 2s2. This is 2p5. This one is 1s2, 2s2, 2p5. If you take hydrogen, the energy of hydrogen will be like this. Here these electrons will not be participated, will not be mixed with these electrons, so these will be remained as non-bonding. These are also non-bonding. In this case, px, py, pz, the pz orbitals will interact with the 1s orbitals of hydrogen. So there is a formation of a sigma bond here, sigma, and here there is a formation of sigma star. Here there is an interaction between 1s of hydrogen and pz orbital of fluorine. So there is a formation of bonding and anti-bonding orbitals, and the remaining two will be non-bonding. These two will be non-bonding. So how many electrons are there in this case? 2 electrons, these 2 electrons, these 2 electrons. From hydrogen 1 electron, and from pz 1 electron. So here there will be 2 electrons, and here 2 electrons will be non-bonding. These are non-bonding. Here the number of non-bonding electrons present in the frontier molecular orbitals. These are the frontier molecular orbitals. These 4 are non-bonding electrons. Here 2 and here 2. So what is the correct option? B is the correct option. The coordination number of aluminum ion and the number of bridging hydrogen atoms in AlBH4 4 times O minus R respectively are. Here this is the structure of AlBH4 4 minus. This is the structure aluminum, and if you take one BH4 unit, let us take this one. This one form 2 bridged. It has 2 bridged hydrogens and 2 terminal hydrogens. If you take one BH4 unit, 2 bridged hydrogens and 2 terminal hydrogens. So if you take this one also, B, you can write 4 B's, and these are hydrogens. These are terminal hydrogens. 2 hydrogens will be participated in bridging, and 2 will be terminal. Here also 2, 2, and 2, and 2. So these 2 will be bridged with aluminum. So number of bridging hydrogen bonds? Aluminum minus, this is minus. How many bridging hydrogens are there? For each BH4 2, 1, 2, 3, 4, 5, 6, 7, 8. 8 bridged hydrogens are there, HBs are there. What is the coordination of aluminum? Aluminum is coordinated with how many groups or how many atoms here? Here 8 groups. Aluminum is attached with 8 groups. So the coordination number of aluminum is 8. So what is the answer? What is the answer? 8 and 8. Okay, coordination number and bridging hydrogens. Both are same here. In coming video, we will discuss the next 10 questions. That is from 21 to 30. Thank you.